let's talk about the Bayes theorem. Let's start with the Bayes theorem. Bayes theorem is used specifically for one reason and one reason only. We know one conditional probability of, for example, A given B. We know that, and we want to know what is the probability of B given A. That is what we want to know. And when we have this situation, we use Bayes theorem. For this example, I'm going to use exactly the same example, the same example in your book. We have supplier 1 and supplier 2, and these suppliers either give us good or bad products. Supplier 1 gives 0.98 and 0.02, the probabilities of good and bad, and supplier 2 gives us 0.95 and 0.5, good and bad products respectively. The probabilities to choose each one of the suppliers, supplier 1 is 0.65, then suppliers 2 is 0.35. So we only have 2 suppliers. If we draw the 3 diagrams, we have supplier 1, supplier 2, supplier 1 is 0.65 and supplier 2 is 0.35, and then from supplier 1 we can get either bad or good products. Bad is 0.02 and good is 0.98, and suppliers 2 exactly the same, bad and good, 0.05 bad, 0.85 good. Now, if I multiply these elements, I'm going to have here what? The probability of B and A1, B given A1 times the probability of A1. Okay? And this is equal to 0.65 times 0.02. I have it already here. It's 0.013. This is 0.637. This 0.637 is nothing but 0.65 times 0.98. This is 0.0175, and this is 0.3325. If I add all these probabilities, guess what? These probabilities are equal to 1 because there are no other possible outcomes. This is it, no more. Now, I know that the probability that is bad given that comes from supplier 1 is equal to 0.02. I want to know what is the probability that given that is bad. So I have this pile of products and I'm going to choose one product, and that product is bad. I know that is bad. What then is the probability that this product comes from supplier 1? Okay, that's what I want to know. If we see over here in the table, we can see that the only way that, it's bad. We know that it's bad. So it either comes from supplier 1 or it comes from supplier 2. Now, my sample space are these 2 elements. That's it. Because I know that it's a bad product. I already pick it and it's bad. So, if we go to the formulas, this is not the one. The probability that comes from supplier 1, given that it's bad, has to be equal to probability of B that is bad given from supplier 1 times probability of supplier 1 divided the probability that is bad given that comes from supplier 1 times probability of supplier 1 plus the probability that is bad coming from supplier 2 times the probability of supplier 2. If we see this is nothing but 0.013, that is this probability, 0.013 divided by 0.013 plus 0.0175, and this is equal to 0.4262. And that is the only way, the only possibility or the only purpose for the Bayes theorem. Now, let's do a problem. Let's do problem number 39. Okay, 39. Problem 39 says, the prior probability for the event A1 and A2 are, the probability of A1 is 0.4, probability of A2 is equal to 0.6, the probability of B given A1 is equal to 0.2, and the probability of B given A2 is equal to 0.5. Okay, so we know this, and we want to know what is the probability of, okay, what do we need to know? Are A and 2 mutually exclusive? What is mutually exclusive? The probability of A intersection B is equal to 0. Yeah, I think in problem it says the probability of A and A1 intersection A2 is equal to 0. So by definition, yes, these are mutually exclusive events. D, compute the probability of A1 intersection B. Okay, probability of A1 intersection B is equal to the probability of B given A1 times the probability of A1. Okay, because we know that probabilities. Okay, check your notes. And the probability of A2 intersection B is equal to the probability of B given, that comes from A2 times the probability of A2. Okay, and what is this probability? This is 0.2 times 0.4, 0.08. And this is probability of B given from A1 is 0.05 times 0.6. This is equal to 0.03. Now, what is the probability of B? The probability of B, okay, is the sum of all these probabilities. Because there is no other way. Either is from A1 or A2. What is the probability of B? The probability of B is equal to 0.08 plus 0.03, and that's 0.11. Now, this is how we're going to use the Bayes theorem. They want to know what is the probability of A1 given B. We know what is the probability of B given A1, but what is the probability of A1 given B? Then you have to say this one. This is equal to probability of B given A1 times probability of A1 divided by the probability of B, because it's the sum of all these probabilities. So you have to say that this probability is 0.08 divided by 0.11. Okay? And the probability of A2 given that B has to be equal to 0.03 divided by 0.11 with the same token. And that concludes chapter 4.